Can you hear me now?
Yes, I can. Good morning.
Good. Okay. All right. So, hmm, all right. So yeah, I can. This needed to be charged up. So let me get your name right. Fiolami. Fiolami. Correct? Thumbs up or
Yes.
down? Fiolami. Fiolami. Okay.
Yes.
First thing. All right. Then now. All right. The next thing now is how can I do this? Uh all right. I should be able to. Aha. Share my screen. Huh? Let me see. So you should be able to see my screen. No, you do.
Yes.
Good. Then let's see now. I should be able to pull up a paint program. Hopefully this will work. I set this up with you in mind here. Uh, Paint 3D. Let's try that. Now, okay. New. Yeah. Uh-huh. Let's see now. Maybe I can make this bigger. Aha. Yeah, I can. So, let me see. 200%. Let's try that. Now I'm going to switch from my mouse to my pad. And instead of using this, I will use this. All right. And I will use this. So let's see if it works. Let's see if God opened up the door so I can teach Fiolami. All right. So now, aha. It seems to be working so far, but I gotta get used to these pens. Aha. Next thing I need to do is learn how in this program to clear the canvas. Once I can do that, we can be doing some interesting stuff. Let's see.
If you go back, there's a place that says eraser, and then you can use it to clean it off.
Oh, well, there you go. Nothing like some help. Okay.
On the right,
Under what?
on the right, that place that has like an eraser icon. Like,
Uh-huh. Where is that now?
you see, like where all those tools are, where it says
Uh-huh.
marker.
Okay. Thank you, dear.
So
Let's go.
on the second
I
row,
can move
the
this
second
over.
one,
Uh-huh. Eraser. Uh-huh.
then you clean it off.
But how do you clean it in one?
You
In
increase, you can increase the thickness, and then,
don't know.
oops,
I don't know where this Igbo came from. I think it
click
was a
undo on top, undo.
undo. Okay. Yeah. I'm getting used to this pen again. What I want is in. Well, this don't need to be 48. Let me try to change that. More like 22, maybe. Uh huh.
Okay, go to brushes on top. Brushes.
Where?
It's in the middle. Yeah, there.
But I want one command that's just gonna clear the canvas like in one. I don't want to have to erase like
Oh,
each stroke. That would take forever. So I want to be able to. I remember this was those. Still getting used to the pen. I can still use the mouse even though I have the pen, so I don't have to be. Don't save. Uh-oh. Okay, get back in there. Alright, so this is important, so let's make sure we get this down and then we can flow. Alright. New. And this is good because if I was teaching something I could actually save it to yeah, 2, 3, 4. I want that about that size. I want to be able to create something here. Boom, boom. But then I want to be able to erase the whole thing. Let's see. Canvas options. Uh, no, 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 no. Clear. I can always do this. I believe that much is easier. Delete. So we have that. So at least we have that. So brushes. Boom. So I'm explaining da 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 da. And now I'm saying no, I'm wrong. So what did we do last time? No, it wasn't that. Oh yeah, we just grabbed the whole thing. No, we did select and then we grabbed the whole thing, right? Then we said delete. Uh-huh. Okay, so we can do some stuff now. All right, now that's for me for show you stuff. Now we have to test you for me, you for teach, you for show me stuff. So I stop share now. Show me stuff now.
Question?
Yeah, whatever. We're testing the right now. We are just testing the mechanics of the online connection. Remember, we are 6,000 miles apart, so the technology have to work.
Okay.
So I just demonstrated that my pad. I found it. I found my stylus pen. I can draw with it. I can I can explain problems on a whiteboard, and I can clear the whiteboard when I'm done. So that far we have gone. Now I need to see you use the technology to show me your problems, maybe even to show me yourself writing or working on something. Like, how would you show me that? Okay, I did this problem and this is my work. Well, how are you gonna show me that?
Okay, so I also have Paint 3D on my laptop.
Nice, nice. I
So
see it. Okay.
I guess we can both use it. And on Zoom, like if we're just quickly doing something like to work, there's a way
Uh
I can
huh.
annotate on your. Do you see this place on top? Like it says annotate. I'm not sure if you can see it.
Uh huh. I
It
can
says
see.
annotate. So actually, you can write on what I am working on.
Oh, nice,
Yeah.
nice.
So even if you are
Okay,
the
wait.
one that is sharing, I can still write on like your screen. But what I write
Oh, wait.
wouldn't stay, but like it will help to see what I was doing at that point in time.
So wait. So even while you're in there, I can still. It look like I can't. I don't think I have access to your functions though.
Um,
I can't. I can't change anything. But uh, but anyway, let's get started. Like so now is where you would use this to pull a problem up and then show me your work, and then I would be able to feedback some information that will help you. So go ahead. Let's try something. But you don't have a pen, so you'd be having to try to write with the mouse, and that's a pain. That's a big pain in the neck.
I can try to work with it. I use it in school sometimes.
All right, we'll give it a try,
Okay.
and we'll go from there. Try the other way too. Like, try see if you can use the camera to put it on your page, and see if you can show me it that way too.
Sorry, I don't understand.
Just try to write on a regular paper and put the camera on it, and let me see how well that works.
Oh, okay.
That's the other option.
I'm not sure if you can see my screen.
I can
Yeah.
see the paper. I can see the paper. Uh, yeah, but let's see you write something on it and show me like you're doing a problem and you want me to look at your work.
Oh, okay.
Okay, fine, fine. That's good enough for me to see the problem.
Okay. But I think let me try another way. Maybe this would be better. I have the paper itself, like what I was working on. So if I share it, can you see my screen to be able to see the
Yes,
problem?
I can. Uh huh. That
So
looks
this be
great.
better.
Yes, that's better.
Okay.
Now, if you can work on top of that, that's the idea. I can watch you.
Can you see what I'm writing? I'm
Yes, I
just
can.
scribbling. So
Yeah, we can. All right, I think we have enough tools now. Let's get to work. So, what problem you want to do?
okay. Can we start from here, please?
All right. So, what is probability means to you?
Um, that is when like I know everything totals to one at the end.
No, I don't mean that. First, always when I do math with you, I always just want to talk about it in terms of just life. I don't go straight to the math. To me, math is life, and that's the reason why I'm so good at it. I don't see any in between. It's a tool and I apply in life. And it is a tool that God has given me an extra ability in. And as a result, I'm able to use it to my advantage over people who don't have this gift. So, in order to pass this gift to you, I have to make this real. I have to relate it to your life. So, I ask you again, what does probability mean?
I think probability is when you try to see the balance between different aspects of life. Like when you try to balance everything in a way, like everything has different sections. So you try to balance them according to the sections it's held in.
No, you're not getting it. Probability is in English, it's just a measure of how likely something is to happen. as it relates to money or something like gambling or something like, you know, what people do when they go to the casinos and stuff. Probability becomes important because people want to know what's the likelihood that if I put this money into this thing, that I'm going to get a return that's more than what I put in. So people do probability and they use this math as a way of gauging what are my chances. Okay. So
Okay.
the key word I was looking for was chance. Okay.
Yes.
So another word that's more closer to life that you can use to describe probability is what are my chances? Understand?
Yes.
Okay. So let's look at this problem. A bag contains blue, red, yellow, and green balls only. One ball is taken like a blindfold. You put your hand in, you don't know which one you're going to pick out. All right. So what are the chances you get a blue one?
Um, 0.15.
What does that mean?
I actually have no idea.
Well, if you had 100 balls, how many? What's the chances you get a blue one?
Um, 15%.
Hmm? 15%. Right?
Yes.
Okay. So that means if you did the experiment 100 times, how many times would you expect to get a blue one?
15 out of 100.
Correct. Same question with the red one.
2 out of 100.
Not two.
Sorry.
Not two.
0.2.
Mm-mm. That don't say 0.2. That says, I mean, it says 0.2, but it doesn't say 0.02. That's what you said.
Oh, 20 over 100.
Correct. If you do the same experiment now with the green, what's the chances you're going to get a green ball now?
43 over 100.
Out of 100. Correct. And the percentage is just so I'm just using 100 as a round figure because they are putting it in terms of decimals, so it's easy to talk about 100 ball sample. But when they say probability is this percentage, I don't have to give you a sweet example like the 100 balls, right? It means that even if it's 20 balls, the chances is going to be 15% of 20, right?
Yes.
But I'm just using the 100 as a way to make it more like life, so we can talk about it. Okay. All right. So if that's the case, now what are the chances out of 100 balls? Now forget a yellow one.
Um, 22 over 100.
How did you get that?
So when you add the blue, the red, and the green, that's going to give you 78 out of 100. So you subtract 100 from 78.
All right. I'm assuming you did that right. 5 and 3. 5, 58, and 27. Good. So then the yellow ball. So the chances of getting a yellow ball out of 100 ball sample is what?
22 out of 100.
Correct. So in this example, what are they looking for in terms of a decimal?
0.22.
Very good. That's the answer. All right. Now, all right. So a ball at random and replaces it in the bag. Hmm. Do you have the answers to these?
The
Just so
maximum?
that yeah, the answer just so I can make sure I'm correct.
Yes, I do.
Okay, good. All right, so let's take a shot at B. I'm not exactly sure. Replaces it in the bag. If that changes the answer or not, let's see. Um,
Sorry.
replaces it in the bag. Replaces it. Replaces it. Replaces it. Yeah, I'm not sure. Replace it with what? What do you think this means? Hmm?
Um, I think I think according to the table that he just randomly took different colors of the balls and then would put them in the bag. So I think the ball doubled in size.
The uh, the problem I'm having is what when it says replaces it. I don't know whether they mean okay, take a ball out and he replaces it at random also with one from any of the four colors. I don't know. If he replaces it at random with any ball of the four colors, then it changes the probabilities. That's the problem I'm having, right? So if he pulls a red one and replaces it with a yellow one, that changes the probability each time he does that. So do you see why I'm having a problem with this problem?
Yes.
Now assuming what they mean is they take a ball at random, like if you get a red one now, and then you put it back with the same color. If you did that, then uh, the sample space doesn't change. Meaning the number of balls. So if you start with 100 and you pull out a red one, they're saying he replaces it. What they are not saying is to replace it with what. So we're having to assume that he's replacing it with the same color. You follow me?
Yes.
Okay. If he's replacing it with the same color, then it's just that it's the same thing. Like he did it 200 times. So the time you expect to find a red ball now is just going to be 20% of 200. Understand?
Yes.
So that's one thing you could ask your teacher. Tell her you were working with your tutor, and your tutor was saying it doesn't specify whether or not you are replacing it with the same color. If you are not replacing it with the same color, it becomes a different problem. It's something that the math can handle, but I would need to know the difference. Understand?
Yes, I do.
Okay. So let's just assume that it means that you are replacing it in the bag with the same color, and then it becomes a reasonably manageable problem where you're just taking 200, and the 200 is like the 100 that I started to teach it to you with. So if it's 200, then it would just be the red 20% of the 200, which we know 20% is what fraction?
20 over 100.
Yeah, but you need to know this quicker than that. Let me show you something. I need you to make a table, and this is just an investment for the future. This is how I will train you. Okay.
Okay.
So go to a piece of paper now, or just well, let's just finish this. So it would be two. So what I'm saying is, point two is 20%. 20% you should automatically know is 1/5. 1/5 of 200 is 40. Okay.
Okay.
So you would expect to find a red ball 40 times out of 200. Okay,
Okay.
but do this for me, because what I will be doing in training training you, it's like, this is not just about the one time we are talking about this test. I see you as being my student for a while. So there are things that I'm going to give you that represent tricks and tips and tricks that come from my toolkit, that if you master them, these things will help you way beyond just this one problem. So the first thing I want to give you is a translation table where you will automatically be able to translate fractions into and or I mean percents or decimals. Well, more or less percents, I think. Yeah, percents into fractions almost automatically. All right.
Okay.
So write this down, and you can put the camera on the page while you write, so I can watch what you're doing.
Okay.
Okay, put it on the page now.
Oh, okay.
Well, no, like you can write it down on you with your regular pen. Just put the camera on a page and just start writing.
Oh,
Yeah, just a regular. Yeah, make sure it stays. This is gonna be your notebook or your notes that we will use. You will use going forward. Okay.
okay.
So give me a fresh page then, and start writing. Put at the top of it. Now you can write. Start right now. But you don't
Okay.
write like. Can you put it so that you can write normally and then have the camera focus down on it, so that you can
Oh,
put the page on the table and then have the camera
I'm
focus down
trying.
on you.
I'm trying
Yeah,
to
you want to be
help.
able to you want to be able to write normally,
Oh, okay.
and then while you're writing, have the camera so I can see what you're writing. It should probably be behind you,
I
if
have no
possible.
idea how I'm going to do that.
Uh, Basically just turn around or put your seat on the other side of the desk if possible.
Oh, okay.
Or I guess, oh, because you're using your laptop camera, huh?
Yeah.
That's kind of, you're using a laptop camera, right?
Yes, I am.
So that's why. Okay. All right. Well, all right. Then don't worry. Let's start writing. Put at the top of the page, say percents to fraction translations or something like that.
Okay.
Percent to fraction conversions. Yeah, that's better. Percents to fractions conversions, right? And then start on the top and write 1/2 equals 50%. And I'm gonna quiz you on this next time. Everything I teach you, it would be like, you ever see the movie Karate Kid
Yes.
with Mr. Miyagi and the little boy?
Yeah.
All right. So what Mr. Miyagi always used to come back, and he used to always tell him, you know, you have to polish the stone. So before he taught you, okay? So
Okay.
that's what I will do. So write 1/2 equals 50%, 1/4 equals 25%, 3/4, and then next to the 1/4, go horizontally so you can do that fourth series. You have the half on the top, 1/4 next line. So you want to have 1/4 equals 25%, then 3/4 equals 75%, Okay. Then on the next, do the thirds now. 1/3 equals 33.3%. 2/3 equals 66.66%. That's approximate because those are repeating decimals, but you get the idea.
Yeah.
So 2/3 equals 66.6%. Then now you go 3/4 is 75%. Then you go to the fifths and you go 1/5 is 20%. 2/5 is 40%. 3/5 is 60%. 4/5 is 80%. I don't do six. I don't do sevens because 4/8 is just 1/2. 5/8 is 62.5%. Don't worry with 6/8 because that's just 3/4. 7/8 is 88.5%. Okay, and let's go to the ninths now. 1/9 is roughly equivalent to 11%. 2/9 is like 22%. 3/9, don't worry, that's like 1/3. 4/9 is like 44%. 5/9 is like 55%. 6/9, don't worry because that's just like 2/3. 7/9 is like 77%. 8/9 is like 88%. And that's it.
Thank you.
9/9 is a whole.
One.
9/10 is equal to 90%. Okay?
Thank you.
So now what's the values? And once you don't even have to look up the table. Because at that point, I'll be able to say to you, for example, what I'll be able to say, what's 90% of 200, and you'll already know that 90% is 9/10. So you'll figure out what is 1/10 of 200. That's 20. So 9/10 of 200 is 180. So when you're practiced up and when you're where I need you to be, I'll be able to say, feel on me. And you'll be like, what, Mr. Biz? And I will say, what's 90% of 200? And your brain will go, okay, from this table, I know 90% is 9/10. I need to get 1/10 of 200, which is 20, and then multiply 9 of them, that's 180. So that's how I want you to think. Once you are applying this table I just gave you, you'll be able to do these things quick, 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 quick. All right?
Yeah.
Mm-hmm. So, and you'll just have a good sense of what the relationship of numbers and fractions, you know? So that's a good tool. All right, now let's move to the next problem and see what we get now.
Okay.
Okay, that one, number 5.
Yes.
Okay, the largest number. Hmm. So let's go through and see what we get. If right, so if n is 0, then the term is 60. If n is 1, let me write this down so you can see how I'm thinking. Hold on. Let me take control now.
Alright.
Mm-hmm. How I do that now?
Guys, stop sharing.
Okay, so now I must share mine then. Uh-huh. Okay, so 60. No, no. I have to get the pen, right? The
Yeah.
brush.
Yes.
Uh-huh. And let me take this on here. Let me see how this go. No, so let me try that one there. 60. Okay. 60 minus 8n, huh? Like that?
Yeah.
Alright, so this what you call a sequence. Uh-huh. So when you're dealing with sequence now, you want to deal, so n equals 1, even 0 sometime, 2, 3, and so on. You want to test out the behavior of the sequence based on this input. You have to think of it like an input. You're putting in to the n. Understand?
Yeah.
Okay. So when n is 0, that is the input. What is the output?
0.
No,
60,
no, no, no,
sorry.
no.
60.
Yeah, this is your function. Understand?
Yeah.
So when you put 0 into the input, what is the output?
60.
Good. When you put 1 in your input, what is your output?
52.
Very good. When you put 2 into the input, what is your output?
36.
You sure?
Um,
6 minus 16, right? So it would be,
wait, no. 44.
right. When 3 is the input, what is your output?
36.
Very good. When 4 is your input, what is your output?
28.
Very good. When 5 is your input, what is your output?
20.
Alright, now, so you see how the sequence work. So now go back to what the question is asking you.
Okay.
What is the question asking you now?
And the largest number in the sequence.
Okay, alright. So you see where this is going.
Yes.
Okay, so the largest number, it depends on whether or not the sequence start with 0 or if it start with 1. That's the only thing you have to figure out because one of these two is the answer. Eh. So which one? That's the thing we have to figure out. Does the sequence start with 0 or 1?
I think it starts with 0. I don't know.
I don't know. Well, that goes back into how they taught you because I've seen them start either way. So go back to the problem now
Okay.
and you can switch back to your screen now because that's just to show you how the sequence work. Now the question is based on that, what is the largest number of the sequence? Does it start with n equals 0 or n equals 1? So go back to the problem, see if they give you a clue. Mm-hmm. Okay, so this depends on how they taught you. and you would have to ask your teacher this one. You can ask your teacher questions, right?
Yeah, I can.
Okay. So ask her, him or her. Is that her or him? Her?
Him.
Him?
Yeah.
Is that him? Okay, so ask him, does n, the set that you're feeding in for the inputs, does it start with the set of uh, natural numbers or whole numbers? If it's the natural numbers, that means, I think, let me just make sure. I think that means the set of natural numbers includes the zero. And I think whole numbers doesn't. Let me just make sure I'm right here. Natural numbers. Uh-huh. Natural numbers, yeah, are the positive integers, just the whole numbers. Oh, wait. And it says sometimes zero. Come on, man. I don't need no sometimes. I need the actual answer. All
If
right,
we check
hold
the
on.
log scheme, then we should be able to know like which one exactly you're
Yeah,
referring
we
to.
would. Yes, we can do that in a second. True. Uh, whole numbers. All right. Definition of a whole number. Okay, so that's including zero. Basic count. So whole numbers include zero. Is zero a whole number? I think they would say, yeah, it is. Uh, yeah. So I believe that a sequence deals with whole numbers. Okay, does a sequence deal with whole numbers? Let's see. What is the rule for number sequence? Oh, integer sequence. Let's see. All right, look at the answers. See if they say 60 or 52, and we'll know whether or not include the inputs includes all of the whole numbers or just the start the integers, the positive integers. I believe it would be 60.
They put 52.
Or they want 52. Okay, so that
Yeah.
means that they're starting with 1, not 0. Okay?
Yeah.
Okay. So that depends on the level of math that you are on, because certainly sometimes later on you'll see sequences starting where n equals to 0. So in this case, n is equal to 1, so just treat it like it starts with 1. Go on to the next problem then.
Okay.
Oh, and did we verify that the answer to the other one was 40?
Oh, my bad. Let me check.
Yeah, just making sure that we are correct.
Yes.
Okay, all right. So that means there was replacement only of the same color. All right. So go on into the next now. hmm
Okay.
Okay. All right, so a sequence. So the first question you have to ask is, what kind of sequence is this? So you're looking for a common difference or a common ratio. Always check the difference first.
7.
So you wanna compare the second number to the first, right? So you subtract them just for the sake of it, because they say sequence, which means you don't know if it's an arithmetic sequence or a geometric sequence at this point. So you have to test it so that you will know. So the first test I would advise is always to see if there's a common difference. Then as soon as you can tell there's a common difference, you already know that it is a arithmetic sequence, not a geometric one. So look at the second term and subtract the first. How much do you get?
7.
Hmm? 7, right?
Yeah.
So when you're analyzing a sequence, the very first thing you would do is draw. Even if you do it in your head, you're drawing a line from the second term to the first, and you are taking a difference. Then you are going to the third term, and you are comparing it to the second. Yeah, yeah. You're actually going the other way. The arrow goes
Oh,
the other way. Okay, you're comparing 19 to 12, right?
okay.
So, so you're drawing an arrow from 19 to 12 because that's what your mind is doing.
Like
Yes,
the
arrow. That is, and what you're doing on that line, you're saying uh, plus 7. Like you're showing that it's 12 plus 7 gives you 19.
okay.
Now you are so there in the maths language. Now you have just figured out what is the difference between the second term and the first. Now you have to see, is it a common difference? So now you want to go to the third term compared to the second now. Exactly. Exactly. Uh-huh. So is that plus 7 as well?
Yeah.
Good. That's a good sign. Then do you want to compare one more time now?
Okay.
Mm-hmm. Okay. What about that difference?
Yes.
So what you have just discovered is you have a common difference. You should record this term so you don't forget. These are terms that you use to describe sequences. So the term here is, I have noticed, let's say we want to, like we wanted to talk about this in English, just chilling, talking, right? I would say, Fiolami, have you analyzed this sequence yet? You will say, yes, Mr. Biz. And I
Yes.
will say, what did you find?
There is a
And you will
common
say,
difference.
exactly, of 7. Exactly. You see how you just talk about it like it's like you're talking about ice cream or Chinese food? Exactly. That's the whole point. That's what I want to do for you. Take this mysticism out of mathematics and make it like Chinese food for you. All right. So plus 7, plus 7. So you have just found there's a common difference of 7. So that means you have identified this sequence to be an arithmetic sequence. So now we have to find the nth term of the sequence. Now that takes a little knowledge that you should have in your toolbox, and if you don't have it yet, we have to put it there. This requires a little formula that you have to know. So let me look it up. That's the nth term of an arithmetic sequence is what you're dealing with. All right. So what is the formula for an nth term of an arithmetic sequence? You see it there? Right there. Okay. That is the knowledge you must have to solve this problem. Okay? Do you have that knowledge?
Um,
Not yet. It's okay. Yes or no?
no.
Okay. So then you probably wouldn't have been able to solve this problem because this is the knowledge that you would have had in your brain. Okay?
Okay.
So what we will do is I will recommend to you that you create a little book of what some of my students I call it just like a little book of index cards, and it's a ring binder and it has the cards in it. I don't know if you can find something like that in Africa. Maybe you can, but it's a small ring binder and it lets you put this like these little index cards in it. And on these index cards, you are putting stuff like this. You understand? Because this is the rule. This is like the rule that you needed to solve this problem. So my part of my job now as your math coach is to get you ready so you can tackle any problem, not just help you work one problem. So this is the knowledge now that you would need to solve any problem like this one here, like what you're doing. Okay?
Okay.
So I need you to write this down just as it is. And for the sake of discussion, we will refer to this as a uh why? As a road sign. That's correct. That's what I used to use. This is what I like to call a road sign. So it's like a sign, like a road sign. So you see the road sign now, you can continue. If you didn't see the sign, you wouldn't be able to continue. You'd be guessing and you'd probably get it wrong. So what you need is this knowledge then. Okay? So now to solve this problem, you have already found that the common difference is 7. So right, so in this formula, the common difference is D. See it there? See it there?
Sorry, are you showing me something? I can't see your screen.
Oops, sorry. Hold on. Uh, uh, Hold on. Switch to me. Share screen. That one. Okay, this is the knowledge you needed. So write that down.
Okay.
All right. So now notice that the common difference is D in this formula. That is what you just figured out.
Alright.
So now we will apply this thing. All right. So let me go back here and let me use the tool that we figured out. Select all of this there, all of this, all of this, all of this, and just say clear. All right. Delete is fine. Yes. Now get the pen and start to write this A. That's too thick, man. Joe. Let's see. A. That's still too thick. Let me try this pen. A. Yeah. Let me try black. A. Yeah. Now let's go back to the stylus pen and see if that's a little better. Oh, come on. Up here. A. There you go. All right. Good. So select. Boom. Grab all of this. No, not that. All of this. And say, no, not that menu. Uh, how did we do this? I didn't do it with the pen last time. Oh, the mouse you can just click right. The pen is a little different, but okay, no worries. I have both of them. All right, so A, jeez, oh, please, hold on. I need the brushes, and I need this brush, and it's in black now, so okay. A to the N equals A1 plus N minus 1 D. Okay, so the sequence then, the expression for the sequence should be A N equals, what's the first term of the sequence?
12.
12 plus, what is N? No,
7.
N, wait, no, N is good. N minus 1. And what's the common difference?
7.
Okay. So at this point, you have an expression. What you want to see is this one in your answers are choices, yes or no.
Mm,
Hmm? Oh, they didn't give you choices. They said figure it out,
yeah.
right?
Yeah.
All right. Well, okay. Then I would take one more step and do this 12 plus 7n, right? Minus 7, right?
Yes.
And then you get 7n plus 5. Okay? So then your sequence would be an equals 7n plus 5. But we have to test it now. And how do you test the sequence?
Puts in
You
one
want,
of the.
exactly, you put in n is equal to 1. Remember, so we learned that last time. They want, just start the sequences with 1. So the first term is what? A1.
12.
A1, does that, when we plug it in, does that give us 12? You put in 1 for the n. So A1, and then you
Yes.
put 1 in. This is your input, remember? That's your input. Understand?
Yes.
Okay, so you put in 1 and you get 12. Yeah. So then now put in 2.
19.
Is that correct?
Yes.
Put in 3.
26.
Is that correct?
Yes.
Put in 4.
33.
Is that correct?
Yes.
All right. Then you have just found the expression for your arithmetic sequence. It is this. That should be your answer. Check it.
Yes, that is correct.
All right. Did you understand that process? Yes or
Yes, I
no?
did.
Good. So what I need you to take from this uh, is is okay. Right. Take from this is that make one of those road sign cards for this nth term of an arithmetic sequence.
Okay.
And next time I want to see your index cards.
Okay.
I'm gonna check on that. So far I'm gonna check on your percents to fractions, and I'm gonna test to see check on to see if you have your index cards, and I'm gonna check to see if you have captured this road sign in your index cards, so that you will never ever have a problem again when you see a question asking you for the nth term of a sequence. Understand?
Okay.
All right.
Yeah.
Sometimes it's about knowledge, and that's what I'm supposed to give you, the knowledge. No guessing, no zen, no eeny, meeny, miny, mo, which is the answer, let's go. No, none of that stuff. All based on real knowledge. Okay?
Okay.
Now, another one, we don't have to cover this now, but just make a note that another sign, another road sign, will be when you test, for example, let's say you had gotten one. All right, the pen is better. The pen is better. This, come on. Oh no, that's not even the pen. Here's the pen now. Okay, all right. So let's say you had gotten 1, 2, 4, and 8, right?
Yes.
And 16, let's see. Now, at this point, you don't know if the sequence is arithmetic or geometric, correct? You don't know. You have to test. So what I taught you was to go like this and test it. First, test to see if it's arithmetic. So you would go here and you would see +1. Then you would go here and you would see, okay, this is +2. Aha. This is not an arithmetic sequence. Okay?
Okay.
That's the first thing you'll notice. The next thing is, okay, if it's not arithmetic, let's try geometric. But when you're looking for a geometric now, you're not looking for a common difference anymore. You're looking for a common ratio. So back to this now. And watch this. Let me use my skills. I think say now, because I know to do this, I can just erase a portion. See? Look here. Get smarter. Look out. Okay, so now we can switch to the mouse now. And we just want to delete just this little section inside the box there. Aha. Good. Okay. So now, let's say we come back here now. We test it now. Compare the two. Oops. Let me go back to the pens. Them. Brushes. Boom. Pen. Boom. Very good. Praise God that I was able to find this stylus. God is good, you know. I'm telling you. All right. So 2 divided by 1 is
Um.
2 divided by 1. You're comparing the second term to the first. You're comparing the
2.
second to the first term. But you're not looking for difference anymore, because that test already went and it failed. Right?
Okay.
So now you're testing for a common ratio. This thing here. All right?
Okay.
You're testing for that. So 2 divided by 1 is what? 2.
2,
4 divided by 2 now is what?
2,
Uh-huh. 8 divided by 4 is now what? Is what now?
2,
Uh-huh. And 16 divided by 8 is what now?
2.
Uh-huh. So you have found a what? Common?
Ratio.
Aha. That means you have a geometric sequence. Uh-huh. All right. So now the next card would be if we was to say nth term of a geometric sequence. That's also knowledge you should have because they could easily have given you this problem and ask you the same thing for a geometric sequence. So I'm just preparing you for that possibility. Um, I'm trying to get this thing to work. Uh-huh. There you go. Okay. Okay. So make your card up with this now. That information right there.
Can you
What
make it a
happened?
bit bigger, please?
Hold on. Just this part should be what you make the road sign with. Okay.
Okay.
Once you have that, you can solve any one of these problems, not just one problem.
Okay. I've written it down.
Okay. So you see now what you have to do. So I'm giving you an example now. See, let's just use this example 1 here. So if they gave you 3, 12, 48, you would try the arithmetic and see the difference is 9 and then something like 36, right? So that's
Yeah.
not arithmetic. Then you would try geometric and you would see the common ratio is 4. All right, so your R is equal to 4. Understand?
Yes.
So now you go into the formula now and you write A sub n like that. equals the first member of the sequence is 3. So you put 3 there. Dot, that means times, and then you put R, that is the ratio. That ratio is 4 to the n minus 1. Okay.
Okay.
So then that becomes the expression for your geometric sequence. You're going to get A sub n equals to 3R, 3 times R raised to the n minus 1. So if you wanted to get the first member of the sequence, R is 4 raised to the n minus 1, so the n minus 1 becomes 0. So 4 to the 0 is 1, so the first term is going to be 3. Does that make sense? I
Yes.
can write it down if you need me to. If you want to see it on here, I'd have to, let me see. There must be an easier way to get this cleared. Okay, so what I'm showing you is A. Oh, give me the pen back. Don't ask me why I can't write all of a sudden. What the heck? Alright. Okay, we got that back. Alright, select. Alright, so A to the n equals A1 R to the n minus 1. So in that sequence, what was it? 3 and then it was 12, right?
Yes. And then 48.
Uh-huh. Okay. And we found that the common difference is D, no, in this case R, sorry. R equals 4. So your sequence then would be A to the n equals 3 dot R. No, actually, yeah. 3 times 4 to the n minus 1. You can't multiply these because that's raised to the n minus 1. Understand?
Yes.
Alright, so let's test it. So this would be if they ask you for an expression for the sequence. Right?
Yeah.
So then let's say they asked you what is the fourth member. So let's test it first. Is A, if we put 1 in for A, that would be 3. If we put 1 in for N, I mean the input, right? N. Then it would be 3 times 4 raised to the 1 minus 1. Well, we know that 4 to the 0, that's 0. 4 to the 0 is just 1, right?
Yes.
So 3 times 1 equals 3. So the first term checks out, right?
Yeah.
And see now if this is the second term, a second, right? Then you're going to get 3 times 4 to the 2 minus 1. So that gives you 1 instead of the 0, right? So 4 to the 1 is 4, and 3 times 4 is 12. So if A2 is 12. Okay, so how can I just move the page around? That's what I need. Just give me the tool to move the page around would be helpful. Come on. Select. Maybe I can move. No. Anyway, go back to this and write. Yeah, that's good. So yeah, if we keep this at 150%, this looks good as far as the my ability to write. No, let me see. A no. What? No, it's messing it up.
You can use the
Undo.
arrows at the side. Is it
Hmm?
nothing for scrolling at the side and at the bottom?
It's good at 150. It was good, so I wanted to go back to that. And certain things the pen is not good for. Like certain things I have to switch to the mouse to do, and that's okay. Back to 150. This is how I want the writing to come out. So I want to be able to switch to the pen now and write on this using the pen, but it's not giving it to me. I don't understand how you can have a pen with the mouse, but then I switch to the stylus and it's giving me a hard time. That's so strange. Select that. Boom. No. Crazy. All of a sudden, things are just crazy. All right. Don't worry about it. I'll just try to use the mouse then. That is a shame. I can't find my mouse now. Come on. Please stop. All of a sudden, it wants to work now. Okay, fine. So, what we found is that a to the 3 is equal to 3 times 4 to the 3 minus 1. So that's equal to 3 times 4 to the second, right? And that's 16. So that's equal to 48. So this means the third member of the geometric sequence is 48. See? So this is the knowledge you need to carry forward on your road sign. That is the key knowledge there. That's how you figure out the nth term of a geometric sequence. Okay?
Okay.
So that's what you need in your toolkit. So if you see any kind of sequence now, based on this lesson, you should be able to figure it out no matter what. Understand?
Yeah.
All right. Now we can go to the next problem. How are we doing on time?
It's 5:03 here. Um,
Hmm?
how
Okay.
long do you have left?
We started at what? 9:30 or a little
Yeah.
after?
Yes.
Okay, we can go to 11:30. I don't mind.
Alright.
Okay, so I'll give you 25 more minutes. Since you have a lot of gas left in your tank, I don't want to waste it. All right, so let's see now.
Okay.
Mm-hmm. All right, so what we're looking at now. All right. Okay, so this fancy word here, trapezium. Don't worry about it. What you want to know is the general rule is this is what you call a four-sided figure. Okay. This is what you call a quadrilateral. Why? Because it have four sides. All right. So let me get my window over here. Just want to check my knowledge, make sure I'm telling you the right thing. Let's see. Quadrilateral. Yeah. Yeah. Quadrilateral. So this trapezium, don't let them tell you these fancy terms and make you lose your mind. This trapezium, what they are talking about is nothing more than a quadrilateral. That means a four-sided figure. That's it. So now, what's the rule for a quadrilateral? It means that now the four internal angles must add up
360.
to, to 360. Uh-huh. And the two the two angles here now, let me see. I believe they must add up to 180. Yeah. So the two on the left must add up to 180. And the two on the right, same thing. So how are you going to set up the formula based on that rule? Show me the work. Do the work and show me the work.
Um, oops.
Dad, you're going to have to get her a pad.
That's okay.
Yeah, get her a pad like mine so that she can write like I was demonstrating. Okay? Then
Okay.
we'll be better off. But she's doing great as you know as she improvises. She's doing great.
All right.
It should just literally plug into her. It should plug into her laptop. No, sweetheart, you're using the rule that says two of the two of the angles on the same side will add up to 180.
Oh,
Yes. Uh-huh. Solve for x now. If you want to take that to the side and do it, that's all right. You don't have to struggle with the thing, because I can follow it. I can do it on the side too. No problem.
I don't know if I'm right.
No, no. The 166 is right, but you have to add up the numbers, then add up the x's.
Okay.
So the next line should be 166 plus 2x equals 180.
Okay.
You understand that plus 5x and minus 3x produces plus 2x, yes?
Yes.
Okay. So you should have 166 plus 2x equals 180 should be your next step. Uh-huh. And then what should be your next step after that now?
Um.
To isolate the 2x, right?
Yeah. So divide each side by 2.
Not yet. The arithmetic come first. So 2x equals 180 minus 166, yeah. And what's that on the right? Equals what?
14.
Uh-huh. So then you can divide out the 2.
7.
Yeah, that's it. Now, if they had given you the 2 bottom angles, you could not use the same rule.
Okay.
Because the 2 bottom ones don't necessarily add up to 180, I don't think. Yeah, they don't. You can just see that.
Okay.
So you would only use this rule for the 2, let me see now. What's the right term? You see, you notice that these are parallel lines, right?
Yeah.
So these angles actually have names. Uh, it's the whole thing when you call like when 2 parallel lines are intersected by what they call a transversal. Have you ever heard of that?
No.
All right, let me switch now to me. All right, so let me segue and teach a little bit. Hold on.
You're not sharing your screen.
All right, one there, one second. Uh, all right, so we're back here again. Let me see. Select all of this, and then switch to the mouse. Click right and delete all of that. That's the easiest thing to do. Then back to the pen now. Good. All right. So what we are saying now? Where was I going with that? Oh yeah, okay. So okay, back. Wait, no, back to the pen. Come.
Hello, Biz. Your camera has shifted.
Huh?
Your
Yeah,
camera
yeah,
has.
yeah. No worries. I just I tilted it down so I could look at the time. All right. So you
Okay.
see here. You see here now. Look. Pretend these lines are parallel. Okay. Parallel lines. You will know them. They will use a symbol like this to indicate that. Huh?
Yeah.
All right. Good. Now, in this case, you had a quadrilateral, and these things were joined together from point to point. But understand now, what you are dealing with is the same situation where you have two parallel lines intersected by another line, which they refer to this as a transversal. Okay, and these are parallel lines. Once you see this situation, which in that problem you couldn't necessarily see it because they gave it to you as a quadrilateral and it looked like this, but they did show you this. So that was the dead giveaway. All right.
Okay.
That's what told you this is a parallelogram. They call it some trapezium foolishness, but that just misleading. First thing you want to notice, it's a four-sided figure. That means it is a quadrilateral. Quadrilateral. But then you also want to notice about this. See there? That's a parallel line and that's a parallel line. So you want to also say now, it's a quadrilateral, which is also a parallelogram. Okay? Understand me?
Yes.
So when you're dealing with a parallelogram, what you know, what I'm teaching you now is that you can use the same language here as you use here. Switch this to red for a second, just for emphasis. This situation and that one is the same. Even though they showed it to you like this, what you must notice now is, aha, these are parallel. And this is a straight line segment. So even if they didn't show you this part, this training I'm giving you now will make it so that when you see this, you will also know that it applies to this too. Which means you are now able to refer to the angles in this the same way. I'll switch to another color. The angles here and here, you can refer to them in the same language as you refer to angles here and here. Okay?
Okay.
And when you're dealing with this situation, these angles have names. For example, this and this now are called same side vertical angles. Have you remember studying this?
Yes.
Okay. This one and this one now are called alternative
Angle.
angles. And this one and this one are called same side something. Let me go figure it. Let me find out what they call that. So, uh, let me see now. Angles formed by parallel lines and traversals. That's what we want. Yes, 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 yes. Very good. Yeah, so this is what I'm teaching now. What are the five angles formed by lines cut by a transversal? Okay, corresponding. Let me see. Okay. All right, good. All right, so this is now what you would put on another road sign. Okay. So this is now the general road sign that applies to any situation, whether they give it to you in a trapezium, or whether they give it to you in a parallelogram, or whether they give it to you in a quadrilateral. It doesn't matter. This road sign is going to teach you now that in any of those situations, because these two lines are parallel, you must relate to it as this thing, angles formed by parallel lines and traversals. Then, once you realize that, you can name these angles accordingly. So, in this, you will see A, F, G, and D are external. A, F, G, and D are external angles. Why? Because they're outside of the two parallel lines. All right? So A, D, G, and F are external angles. Exterior angles. And what they are referring to is exterior, meaning outside of the two parallel lines. See? A, D, G, and F. They're outside of the lines. Understand me?
Yeah.
Understand me?
Yeah.
Okay. Now watch here now. B, E, H, and C. B, E, H, and C are angles that are internal, inside of the parallel lines now. So that's called interior angles. Okay? Now watch this now. This is the one that pertains to the problem we was just doing. B and E, H and C. Look here now. B and E, H and C are called what? What does this say here?
Consecutive interior angle.
Aha. Right. And then A and G, F and D. A and G, F and D are called what? Alternate exterior angles. Now, why are they alternate? Because they're on either side of the transversal. So if they're on the either side, it will be alternate. They will use the word alternate. If they're on the same side, they will refer to them as same side of the transversal. Understand?
Yeah.
Okay. So you can take this now, even if you want to use the same link, because you can browse on links, right?
Yeah.
You can browse. So you, even if you want to take this particular link down and make a note, because then you'll be able to come back here on your own and use this information to make a nice road sign. You understand? The road sign you create now should have this picture, and it should have, if you want, you can utilize this text in here. But the main thing I wanted you to understand is this is the language you can use in any situation that they give you where you're dealing with two parallel lines and a traversal. Even if, like in the problem, they give it to you in this thing them called trapezium. Whatever the heck that is, it don't help because it introduces a different term and doesn't really make you see the connection between this so-called trapezium and this lesson, which is parallel lines cut by a transversal line. You understand?
Yeah.
So now that you have this understanding, the rule that we applied in solving the problem previously is the rule that says, and this should be on your road sign too, they can be separate road signs. You can have one for this stuff, and then you can have another rule for a separate road sign that says, aha, whenever I see a four-sided figure where two of the sides are parallel, even though this is a quadrilateral, it's still the same situation with two parallel lines cut by a transversal because one of the sides is the transversal. You understand? So the rule that you just applied is that consecutive interior angles add up to 180. See? You understand me?
Yeah.
See? Look here. In this figure on the left, this one now. This one right here.
Yeah.
Angle E and angle B are called what?
Consecutive interior angles.
Exactly. And notice in this one now, I'll even call it the same thing. In this figure for the same problem we just solved. This is the A. And this is the, what was the other angle? D?
Yeah.
Is D, right? So this is the A and this is the D. You understand?
Yeah.
So A and D, even in this figure now, this so-called trapezium, what you needed to know was A and D are the angles in the trapezium or in the parallelogram, which are, you fill in the blank, which are blank. What kind of angles?
Consecutive interior angles.
Aha. And what's the rule now that goes on the other? You want two road signs, one for this stuff and then one for this stuff. What may I give you right now? So this rule now is two angles that are consecutive interior angles add up to 180. Exactly. So that's what you did to solve the problem. You took the expression, you said A plus D equals 180. But I wanted to take the time to segue and teach you the roots knowledge so that you could make a road sign out of it, right? So not only would you solve this one problem, but you'll be able to solve a host of other problems that involve parallel lines cut by a transversal. You understand?
Yeah.
Okay, so this is the rule you use. Consecutive interior angles of a quadrilateral add up, really actually of a parallelogram, add up to be 180. Okay?
Okay.
Good, good, very good. All right, so let me see. We have enough time for one more problem.
Okay.
All right, I'll stop sharing now. Your turn.
Can you
So
ask me?
yes. So number 9.
Yeah.
That's the one?
Yes.
All right. So what's the 3 types of factoring?
Quadratic factorization.
Not that one. So that's like a 4th kind. The 3 main kinds that what you can do without using the quadratic formula. And keep in mind, quadratic formula only applies to trinomials, so don't get confused.
Okay.
And trinomials mean 3 terms, right? You know what a trinomial looks like. So quadratic can only be used in situations where you have a trinomial equals 0, and the trinomial is not very friendly. In other words, it don't factor too good. If that's the case, you use the quadratic formula, because the reason why normally that happens is because the roots them are not integers. They fall in between integers. So sometimes you have to use the quadratic formula to find roots that are not whole numbers. That's what you use that for. But in a situation like this, you only have 2 terms. So you don't get to the quadratic. Quadratic is only when you're only dealing with, first of all, you have to be dealing with equations. All right. And this
Yeah.
is not an equation. Secondly, you have to deal with equation where it's a trinomial equals 0. And third, it has to be a situation where the trinomial is not friendly. It's just terrible. You can't factor the thing at all. Then you just say, okay, whatever. You look at the coefficients. A equals this, B equals that, C equals this, and then you plug it into the formula. Minus B plus or minus the square root of B squared minus 2AC over 2A. Okay? So that is something else. That is something else. But when it says factor completely, you look upon this thing and you say, okay, the first thing I must do is remove the common factors. Now, the second form of factoring is when you have a difference of two squares. And that's another thing I will have to segue and teach you next time. You will need a table of perfect squares. Like you'll do, matter of fact, do that for homework, right? Make yourself a table. You say 1 squared is 1, 2 squared is 4,
4,
3 squared is 9,
9,
4 squared is 16,
16,
5 squared is 25, 6
25,
squared is 36.
36.
Yeah, and you go all the way up to 20.
Okay.
All right, that's another thing. Like the fractions to the percents that I want you to know automatically without even thinking. You want to know all of your perfect squares from 1 to 20. And then after that your perfect cubes from 1 to 10. Okay? We'll get there. But these are things I want you to know, that you can automatically recognize a number that's a perfect square or a perfect cube. Okay?
Okay.
So, when you factorize completely, the first thing what you must do is, if you don't see a trinomial and you don't see perfect squares, then it's going to be the first form of factoring, which is to pull out the common factor. There's 3 types of factoring: pull out the common factor, difference of two squares, and trinomial. This is not a trinomial because it doesn't have 3 terms, so that one gone. This is not a difference of 2 squares because you don't see a difference. It's a sum. That's number 1. Number 2, you don't have perfect squares right there anyway. None of them. 21, 28, they're not perfect squares like 36 or 16. You understand?
Yeah.
Okay. So you want to take the common factor. 21, 28. What is the common factor?
7.
Good. Write that down. All right. Now, a squared and a. What is the common factor?
A.
All right. Write that down. Are there any other common factors? There's no b in the first one,
No.
right? Okay.
Yeah.
So now you draw your parentheses. One big one, and then move over to the right. A while. Move over to the right and draw another one. Yeah. Close one. And then put in the middle a plus sign there. No, in the middle.
Oh.
In the
Okay.
middle. Put a plus sign there. Uh-huh. So now in the first position, you're looking for the thing that remains once you pull out the 7a. So after you pull out 7 out of 21, you divide out the 7, you're left with 3. Okay. And then you're left with an a. Uh-huh. And in the back part now, you're left with a what?
4.
Uh-huh. Uh-huh. And a what?
And B.
Yes. Okay. So now you have a good stab at the answer. But always, and this is now just a practice now, this is what you're getting from me as my student now. Anytime you pull out the common factor now, you want to test it. Never do these problems and don't test when you're done. So now you want to test it now. So you go back in now. Now draw a line from 7a to the 3a underneath.
Okay.
You can change the color.
I should draw a line.
Yeah, change the color.
Like,
Yeah, that's fine. Put no to the tree 8. Yeah, and put an arrow there. Okay. Yes. That's the I'm showing you the distribution process. Then now you go to the second thing and draw a line from the 7A to the plus 4B. That means all of it, not just the 4B, but to the plus 4B. Uh-huh. So understand that the plus is part of the second term, right? Okay. So the first arrow is gonna when you multiply that back in, do you get what you started with? Yes or
yes,
no?
yes,
You get 21A squared, correct? So
yes.
that's a check. So this is I'm showing you now what, let's say on a test, you would be doing in your mind. You wouldn't even write this down. Understand me? This is just a check to make sure your work is correct. All right? So
Okay.
then now, on the second term now, which includes the plus sign now, you are multiplying now 7A and 4B and plus 4B. And you want to make sure that you end up with a plus 28AB. Is that what you end up with?
Yes.
Okay, so you can have confidence in this answer. Go ahead and look it up.
Okay. Yeah, that's the answer.
Uh, where is it?
Number 9A. Here.
Okay, right. Okay, good. Good, good, good. So that's the fine. Okay, good. All right. So then do the next one and that's it for today. Just do it
Okay.
on your own now. So you're doing B now. Set it up the same way I showed you. Well, are you asking those questions though? What type of factoring is this?
It's the same as before.
Okay. And it is a difference, but is 20 or 45 a perfect square?
No.
Good. That's what you needed to see. Because if I change this problem to 16x squared minus 36y squared, would that change your strategy?
Yes.
Okay, good. We'll talk about that next time when we talk about how to factor the difference of two squares. Different from this. Understand? Okay. So you're pulling out the 5 and then, okay, you're drawing the parenthesis. Yes. And then you put it in the middle of mine. Okay, okay, okay. Then what now? Mm-hmm. Mm-hmm. Okay. Wonderful. Yes. Uh-huh.
And
That's it. That's all you can do with this one. So you can check it. Well, wait.
it
And
said
you was doing it.
simplify to
Yeah, and you were doing the
completely.
right thing, but I stopped you. Wait. Go and do it
Yeah.
now. The
Okay.
instinct should be to check it in your mind. So show me in with the arrows what you will do in your mind very quickly once you do a factoring.
Okay.
Okay, go ahead, show me. You wouldn't do this on paper now. You would be doing this maybe with your finger or something, or just in your mind now. You're checking. Okay.
20x squared
Uh
and
huh.
then 45y squared
Yeah. Wait. You didn't multiply. You must include the negative in that. You must
minus
include.
minus
Yes.
45y squared.
Yes. And so, can you have confidence in this answer now?
I don't think we're done because can't 4x squared and minus 9y squared. And those square numbers.
Aha, aha. Good one, good one. So this would be the first step, right? Then factor completely means you have to examine what you end up with, right? So you're
Yeah.
good to go on that now. So this is where you would, to solve the difference of two squares now, you would set that up with a parentheses, left and a right, and then another one, left and right, right. And then you would put plus in the middle of one, uh-huh, and minus in the middle of the other one, yep. Then you would put in the first two positions would be the square root of x of 4x squared, which is what? 2x, uh-huh. And then that goes in the other one. No, don't do the other one yet. Go to the other one and put the 2x in over there too. Yes. Yes. And then now what goes in the second slot for each of them now is the square root of the second term, which is 3. Uh-huh. Y. Uh-huh. Okay. Uh-huh. Yep. Yep. And now make sure you bring down the 5 from above.
So do
Uh-huh.
I put it in both?
Nope. Just the 5 in the front now. That was the first part of the problem, to get rid of the 5. But then you notice, oh, I have a difference of 2 squares in the bracket now. So I have to factor that separately. But the 5 is still there out front.
Okay.
Okay, so good one. So you can have confidence in this answer now. So check it.
All right. Yeah.
Okay, good. So yes, this has been very successful. I think we got through those technical challenges quickly, and we were able to use the tools on both sides. You did well to use your Paint program to show me your work, which was wonderful, and I did the same over here. I think it would be one enhance when Dad gets you the pad to make it easier for you to write and show me your work. Using a stylus like this and a pad like I have, that will help us to flow a little better. But other than that, I think we did good.
Thank you.